You would have to eat 20 million bananas to get the same amount of radiation from a single isotope from Fukushima. But Ken is going to spin it the other way.
We heard about bananas and we shouldn't make the comparison, but I think actually I disagree a little bit. If we look at the radioactivity and the response, these are beta emitters that have similar energies, and so we actually can make some comparisons. But the point here on this slide is that there's much smaller amounts of radiation in the ocean that we can measure than are generally considered harmful to us.
You would have to eat 20 million bananas to get the same amount of radiation from a single isotope from Fukushima. Cesium-137 forecast showed a near-surface radiation cloud over Texas, and so each one of those isotopes is equal to 20 million bananas. Hot particles bombarded the west coast of U.S. Each one of those particles are equal to 100 million bananas. And hot particles found at 2 out of 3 U.S. monitoring stations during April, all of these are 2011, is equal to hundreds of millions each of these isotopes of bananas. So one isotope is equal to hundreds of millions of bananas. So a single isotope from Fukushima puts out as much energy as the radiation potassium-40 of 20 million. And so bananas shouldn't be in it, obviously. Why is he doing that? Well, here's the reason, and it's pretty startling. Probably the most important thing you'll ever hear about this subject, and it'll explain the most. I'll cover it after. You'll probably figure it out, but I'm going to cover it all after just to make sure everybody gets it.
Now, I do want to put this in perspective from health safety. I'm not a health physicist by any stretch, but I do want to point out, and I'll go back to, there are about 12 becquerels of potassium-40 in bananas. There are levels of concern for drinking water in the U.S. It's about 8,000 in those units. They have a regulatory limit of about 90,000. So they're allowed by law to put up to about 90,000 becquerels per cubic meter of cesium in the ocean by the operating license of TEPCO. Our plants have similar things. They're allowed to have certain levels in the ocean. That's because these are considered safe. And what we'll talk about at the last part of my talk is, well, what does that mean also for, that might be safe for your exposure, but what about the uptake into fish that we might be eating? So I'll end my talk with the seafood side.
So there's 12 becquerels of potassium-40 in bananas, and if you eat it, you off-gas 12 becquerels of potassium-40 from your body. It regulates it, just like a thermostat regulates the temperature in your house. The map you're looking at is around 1,000 to 1,500 miles offshore, and so I needed to include that to make sure you understand what you're looking at.
But I do want to point out, and I'll go back to, there are about 12 becquerels of potassium-40 in bananas. There are levels of concern for drinking water in the U.S. It's about 8,000 in those units.
The reason you're allowed 8,000 becquerels of potassium-40 in your drinking water is because it's harmless. It's innocuous. You drink it, you off-gas 8,000 becquerels of potassium-40. It doesn't belong in the conversation.
They have a regulatory limit of about 90,000.
So that's 90,000 of potassium-40, and you would off-gas that. That would be extremely high and unusual, but you would off-gas that if you drank that, because potassium-40 doesn't stay in your body and accumulate.
So they're allowed by law to put up to about 90,000 becquerels per cubic meter of cesium in the ocean.
So you're allowed now, all of a sudden, to put cesium in the ocean, but we were talking about potassium-40. See how he just switched that? So it's not legal, because if you had that much cesium in your water, or your tap water or something like that, 90,000 becquerels, you couldn't turn the tap on. You would just get irradiated immediately, because that's insanity, of course, and cesium doesn't travel by itself. It's going to have the uranium, plutonium, 30 times more strontium. But this is the game he's running, and that's not all. Wait till you get a load of this.
By the operating license of TEPCO, our plants have similar things. They're allowed to have certain levels in the ocean. That's because these are considered safe.
So he says because it's considered safe. It would be if it was potassium, but what he switched to was cesium, see? They took potassium, used those numbers for cesium, and now he says it's safe to release it. The licensing agreement for all nuclear plants is they're supposed to put this in a sarcophagus, in a man-made structure, not in a hole in the ground, but in a man-made structure where it sits for a couple of 100,000 years. Now he's claiming because it's equal to potassium-40, right, they flipped it. But then he says cesium. And that's what makes it so dangerous. That what makes this so scary is they have to lie and manipulate potassium-40 into the conversation to come up with those numbers. That's what makes this so vital, that they can't keep doing this. We have to stop that. That's how they're getting away with it. That's how they're destroying the entire planet. And if there was anything safe about it, they wouldn't be using potassium-40 in the equation. They would just say it's harmless. We know it's not. We know they're supposed to lock it up. We know it went through a chain reaction and becomes many, many times more dangerous and lasts for a long time. Certainly not like a half-life. You have to multiply it by 10. So it's not a half-life, it's times 10. And the lies are endless. He even goes as far as to say the ocean is mostly uranium-238. It's not the same stuff that you get from a nuclear reaction. That's how they do this. They name it the same, and then they claim it's the same, but it's not.
And what we'll talk about at the last part of my talk is, well, what does that mean also for, that might be safe for your exposure, but what about the uptake into fish that we might be eating? So I'll end my talk with the seafood side.
And he says it's safe for your exposure, and then we'll talk about how is it for the fish. So he equated it all with bananas, and then he's going to equate it as harmless also for the fish. That's an outright lie. He shouldn't be at this. He only showed up the minute Fukushima happened.
So this event happened. I had actually moved out of this field, but when we heard about the accidents, we immediately knew we had to get there. And this is just a picture of a ship from the University of Hawaii. We were very fortunate to find very quick funding. This is in June of 2011.
He was there at Chernobyl, didn't do nothing for that entire time, then he shows up for Fukushima all of a sudden. If that doesn't raise your suspicion that he's now saying potassium-40 is the equivalent of these isotopes, when that's impossible, and it's an outrageous lie, and he knows the difference, but he's going around giving all these lectures and getting all that airtime, and that makes it a scary, scary, scary thing that they have to lie like that.
And that applies to both things like cesium or potassium-40.